Dear students, here we are going to discuss a new lesson in our electrochemistry chapter for the NEET preparatory students. So today we are going to discuss about galvanic cells and EMF of the galvanic cells. Galvanic cell is a cell in which electricity is produced with chemical reactions. So here they are also called as voltaic cells. Here we have two half cells, one is anode half cell and other one is cathode half cell. Here the chemical reactions, nature of the chemical reactions are redox chemical reactions. So here at anode half cell oxidation will take place and at cathode half cell reduction will takes place. In this lesson, here the first question is the cell reaction of a galvanic cell. So here they gave us a galvanic cell. This is said to be a cell notation. In any galvanic cell, it is represented with a cell notation. In this cell notation, the thing that you have to remember is left side we represent anode. Here it is Cu, represent it as Cu oblique Cu plus 2. Then there is two vertical lines indicating salt bridge, then Hg plus 2 slash Hg. So this is galvanic cell. So left hand side, this is anode half cell and this is cathode half cell. In anode half cell, oxidation will take place. In cathode half cell, reduction reaction will take place. So the cell reactions are here copper oxidizes as Cu plus 2 at anode by liberating 2 electrons and at cathode Hg plus ions by accepting 2 electrons they converted into Hg. These are the cell reactions. Half cell reaction, we call it as a half cell reaction. This is anode reaction and this is cathode reaction. Now they are asking overall cell reaction. Overall cell reaction is copper is oxidized as Cu plus 2, Hg is reduced as Hg. On combining these two equations, we get Cu plus Hg plus 2 gives Cu plus 2 plus Hg. This is net reaction that takes place in this present galvanic cell. So here in these options, fourth option is correct. Next, the cell for which the cell reaction is. Here also in the previous case they gave cell notation and they ask us for cell reaction. Now they are giving cell reaction and ask us to write the cell notation. So the chemical reaction here is H2 is converted as H plus, Cu plus 2 is reduced as Cu. That means hydrogen acts as anode and copper electrode is acting as a cathode. So anode reaction can be represented like this. Since it is gas, we have to take a platinum rod with hydrogen gas atmosphere. So we have to mention the pressure also, that is 1 atmosphere pressure. Then H plus ions, we have to mention the concentration of H plus ions also. In standard state it is 1 molar concentration, 1 m. Then salt bridge is represented with 2 vertical columns. Then cathode, electrolyte in cathode is Cu plus 2 ions and we have to mention their concentration at standard conditions, it is 1.0 mole concentration, then slash, then copper electrode. This whole thing is said to be cell notation. For this reaction, what the reaction? H2 plus Cu plus 2 gives H plus Cu. This is cell reaction. For this cell reaction, the cell notation is this. Next, which metal will dissolve if the cell works? Here the cell is Cu slash Cu plus 2, vertical columns salt bridge, Ag plus slash Ag. So this is a galvanic cell. So in galvanic cell, this cell is anode. Left hand side is anode, right hand side is cathode. Now at anode, oxidation reaction will take place. Oxidation means copper converted as Cu plus 2 ions by liberating 2 electrons. This is anode reaction. Then cathode, at cathode, Ag plus ions taking 1 electron reduced as Ag. So here copper converted into Cu plus 2 ions, and these ions goes into the solution. So the Ag plus ions in the solution will converted into Ag and deposited at cathode. Now our question is, which metal will dissolve if cell works? Which metal dissolves means copper converted into copper ions and goes into the solution. That means copper dissolves into the solution. So here chemical reaction AgCl plus H2 gives 2HCl plus Ag takes place in a galvanic cell represented by the cell notation. Now they ask us to write the cell notation. So the cell reaction is AgCl plus H2 gives HCl plus Ag. Now here in AgCl, silver is in the form of Ag plus ions. In hydrogen, it is exist as H2 molecules. In HCl, hydrogen will exist as H plus ions and silver in atomic state. Now this is the cell reaction. If you carefully observe, H2 is converted as H plus. How H2 will converted as H plus? H2 will converted as H plus. H2 will converted as H plus by losing 2 electrons. That means it is oxidized. If it is oxidized, it will act as, this reaction will take place at anode. Now Ag plus ions converted as Ag. So Ag plus ions converted as Ag. So it will happen when Ag accepts 1 electron. That means it is reduced. So reduction will take place at cathode. So to represent this cell, we have to first represent anode. Anode will be represented as platinum because it is a hydrogen electrode, H2 gas. We have to mention its pressure. Generally it is in 1 atmosphere pressure, then 1 vertical line, then H plus ions. We have to mention the concentration also, because instead of H plus ions you can write HCl also, because this H plus ion, HCl will give H plus ions to hydrogen and Cl minus ions to chlorine. So we can mention like this, and we have to mention the concentration of H plus ions. Then first Ag plus then Ag. So this is the cell notation for the given equation. So here so this can be AgCl, Ag plus ions. So second option, because here AgCl solid was given, solid is not present. Here also AgCl solid was given, it is not present. Here Ag solid is given, this is also wrong. So only correct option is this. Second option is correct. Now, which is correct for the cell reaction? So correct for the cell reaction. So here the cell reaction will depend upon the electrode potentials, either oxidation potential or reduction potential. With the help of those reduction potentials, we have an electrochemical series. According to this electrochemical series, zinc stands on the top, then Ag, because reduction potential of zinc is minus 0.76 and Ag is plus 0.80. The element which is having less reduction potential will oxidize itself. So zinc will oxidize and it can reduce Ag plus ions. So the cell reaction may be written as Zn will oxidize as Zn plus 2 plus 2E minus, whereas Ag plus ions take those two electrons and converted as Ag. So when zinc reacts with silver, zinc replaces or displaces or precipitate Ag plus ions from its solution as Ag, and zinc will goes into the solution as Zn plus 2. This is the only possible reaction. So this first option is correct. Stronger the oxidizing agent, greater is the stronger the oxidizing agent. Stronger the oxidizing agent. In electrochemical series, active metals lithium, sodium, potassium, they stands on the top of the electrochemical series. They are reducing agents. Chlorine, fluorine, oxygen, this present at the bottom, they are oxidizing. So in the electrochemical series, from top to bottom, reduction potential will increase, oxidation potential will decrease. So here the question is stronger oxidizing agent. Stronger oxidizing agents means which are present in the bottom of the electrochemical series in the reduction potential. That means more reduction potential, that is reduction potential with positive value, and less oxidation potential. Those elements which are having these characters, more reduction potential or less oxidation potentials, will act as oxidizing agents. So more Rp, less Op. So oxidation more, greater reduction potential. Greater reduction potential or less oxidation potential. Those elements which are having more or larger reduction potential or less oxidation potential will act as oxidizing agents, and vice versa. Less reduction potential and more oxidation potential will act as oxidizing agents. The spontaneity of the cell is correct. Spontaneity of any reaction will depend upon delta G value. So for a spontaneous reaction, delta G should be negative. Then delta E, that E cell, should be positive, and equilibrium constant K should be greater than 1. These are required conditions for the spontaneity of the cell. Now here in these options, delta G is negative but E is equal to 0. So E is always positive. For a spontaneous cell, E should be positive. So fourth option, only delta G is given. So delta G is negative. Next, the cell reaction is spontaneous. The cell reaction is spontaneous when, just now we discussed that delta G should be negative, delta E should be positive. So delta E is negative, not spontaneous, delta G is positive, not spontaneous. So delta, third option is correct. Next, which of the following statements is wrong? Which of the following statement is wrong? For a galvanic cell, in a galvanic cell, we have two half cells. We have two half cells. One is anode, other one is cathode. Anode is represented with positive sign, cathode is represented with negative sign. At anode, oxidation will take place. At cathode, reduction will take place. Sorry. Anode is represented with negative sign. Anode is represented with negative sign and cathode is represented with positive sign. So this is galvanic cell. Now cathode is positive electrode, cathode is negative electrode. Electron flows from cathode to external circuit. Reduction occurs at cathode. So whether it is a galvanic cell or voltaic cell, reduction occurred at cathode. Reduction occurred at cathode. Now they are asking electron flows from anode to cathode. This is also correct. Cathode is represented with positive sign. This is also correct. So here the option 2 is wrong statement. So answer is 2. The following statement is correct with respect both electrolytic cell and galvanic cell. Electrolytic cell and galvanic cell. In electrolytic cell, electricity was produced, chemical reactions will takes place due to the conductance of electricity. That means electrical energy was converted into chemical energy. In galvanic cell, chemical energy will be converted into electrical energy. In both the cells, oxidation takes place at anode, reduction takes place at cathode, both in galvanic and electrolytic cells. Oxidation at anode, reduction at cathode. But while representing the anode and cathode, in electrolytic cell, anode is represented with positive sign, cathode will represented with negative sign. Whereas in galvanic cell, anode is represented with negative sign, cathode will represent into positive sign. So here one is galvanic cell, another one is electrolytic cell. In both the cases, oxidation at anode, oxidation at anode, reduction at cathode, reduction at cathode. Here in galvanic cell, anode represented with negative sign. In electrolytic cell, anode represented with positive sign. Here galvanic cell, cathode represented with positive sign. Here in the electrolytic cell, cathode represented with negative sign. So this is the only difference. In both the cell, anode is shown by positive sign, this is wrong. In both the cells, cathode is shown by negative sign, this is also wrong. In both the cell, reduction reaction takes place at cathode, yes, this is correct statement. In both the cells, oxidation reaction takes place at cathode, so this is wrong statement. So oxidation will take place at anode. So correct option is third option. Now saturated solution of KNO3 used to make salt bridge because, so salt bridge, to maintain the neutrality in the two half cells, we use salt bridge. In salt bridge, a KNO3 salt or any ammonium nitrate or KNO3 salts will be dissolved in agar-agar gel and it will be connected with the two half cells with a inverted U tube. So here the main purpose of this is the salt should have both anion and cation should have equal mobility, that means they should travel with equal speed to reach the two half cells. So here they are asking the KNO3 used to make salt bridge because why we are using KNO3? The velocity of K plus ions is greater than NO3, no, wrong. Velocity of NO3 ions greater than K plus, no, wrong. Velocities of K nearly same, this is the correct option, that is third option is correct. We are using KNO3 because both ions will move with equal velocities and reach at the same time to the two respective half cells. In a galvanic cell, electrons flown from, just now we did, in a galvanic cell we have anode half cell and cathode half cell. In anode we already discussed that oxidation will take place. When oxidation takes place, metal converted into metal ion. So electrons are released here. These electrons will travel through external circuit and reach battery, and they reach cathode. That means electrons will move through external circuit towards cathode. So galvanic cell electrons flows from anode to cathode through solution. This is wrong. Cathode to anode through solution. This is also wrong. Anode to cathode through external circuit. This is correct answer. The function of a salt bridge. Just now I told you that function of a salt bridge is to keep the neutrality, electrical neutrality in the two half cells. Which of the following is correct? Which of the following is correct? Zinc acts as cathode in Daniell cell. In Daniell cell we are having zinc and copper. So when zinc and copper are there, zinc will act as anode and copper will act as cathode. So in Daniell cell, zinc will act as anode. So here they are asking acts as cathode. This is wrong statement. In lithium zinc couple, zinc acts as anode. So anode means high electropositive elements. High electropositive electrochemical series, lithium will present on the top, zinc on the bottom. So zinc will act as lithium will act as anode and zinc will act as cathode. But in the case of zinc and copper, because copper is below zinc, in that case zinc will act as anode. In the case of copper, zinc will act as anode. But when compared to lithium, lithium will act as anode and zinc will act as cathode. So this is also wrong. Copper displaces iron from its salt. So in electrochemical series, iron is present above zinc. In the electrochemical, iron below zinc. So Fe is below. So zinc can copper displaces iron. Just now I'll give you. Copper displaces iron from its salt. So in electrochemical series, lithium, sodium, potassium, all are present at the top, then Fe. Copper is at the bottom. Copper value is plus 0.34, iron is minus 0.52. So iron can displace copper ions from its solution, but copper cannot displace iron. So copper displaces iron from its salt solution. This is also wrong. Zinc displaces tin from its salt solution. Yes, this can be done because tin is below zinc in the electrochemical series. So zinc can displace tin ions from its salts. Standard reduction electrode potential of three metals A, B, C are respectively. So B is minus 3.0, B minus 3.0 volts, then C minus 1.2 volts, then A plus 0.05. So the element which is present on the top with the least reduction potential can displace these two from their solutions. That means B can displace C and A from the solution. So here what they are asking, the reducing powers. So reducing power, B is maximum reducing power, then C, then A. These are the reducing powers. B is greater than C is greater than A. First option is correct. The difference potential of two electrodes in a galvanic cell is known as EMF. The difference between electrode potentials of two cells in a galvanic cell, that means EMF of a cell, is equal to reduction potential of cathode minus reduction potential of anode. So this is difference between the reduction potential of two half cells. Or if you have oxidation potentials, oxidation potential of anode minus oxidation potential of cathode. In the case of oxidation potentials, anode minus cathode. In the case of reduction potentials, cathode minus anode. Whatever it may be, EMF is the difference between the electrode potentials of two half cells. Zinc gives H2 gas with H2SO4 and HCl, but not with HNO3. So here zinc, when reacts with HCl or H2SO4, it liberates hydrogen gas. But same H plus ions are present in HNO3. In HNO3, we have H plus ions and NO3 minus ions. So out of these two ions, when zinc is reacting, instead of H plus ions, NO3 minus ions are oxidized in place of H plus ions and produces, with preference to H3O plus ions or H plus ions, NO3 minus ions will reduce as nitric oxide. NO2 gas is liberated. Now, at 298 K standard reduction potential for the following reactions are. So, some standard reactions potentials are given. They are, first let us write negative ones first, Zn, because it is minus 0.76, then chromium, this is minus 0.74, then hydrogen, this is 0, then Fe plus 2, Fe plus 3 oblique plus 2. This is plus 0.77. Now, strongest reducing agent which is present on the top of the electrochemical series with respect to reduction potentials. So, zinc is the powerful reducing among the given electrodes. The standard electrode potentials of four elements A, B, C, D are minus 2.65, minus 1.66, minus 8.0 and 0.86 volts. The highest chemical activity. So, A minus 2.65, B minus 1.66, C minus 0.80, D plus 0.86. So, chemical reactivity, an element is chemically more reactive if its reduction potential is too low or too high. So, if its potentials are too high or too low, they are more reactive. They are more reactive. So here in this case, element A is more reactive among the following. Next, when zinc piece is kept in CuSO4 solution, copper get precipitated. When zinc is placed in copper sulfate solution, it will give us ZnSO4 plus Cu. That means here zinc is oxidizing as Zn plus 2, whereas Cu plus 2 is reducing as Cu. That means zinc reduces copper because its reduction potential is less than copper. Zinc reduction potential is less than copper. That's why it reduces copper. So standard reduction potential of zinc is more than copper, so it is not wrong. Standard reduction potential of zinc is less than copper, this is correct. So atomic number is no way concerned, so option 2 is correct. Standard electrode potentials are for Fe plus 2 and Fe, it is minus 4.4, Fe plus 3. When Fe plus 2 plus 3 and Fe blocks are kept together, then, so here Fe plus 2 reduction potential of Fe plus Fe is minus 0.44. So Fe, then Fe plus 3 oblique plus 2, this is plus 0.77. So here iron Fe has tendency to convert as Fe plus 2 because its reduction potential is negative value. Then Fe plus 3 to Fe plus 2, it is positive value. So Fe plus 3 has tendency to convert into Fe plus 2. So when these three Fe, Fe plus 2, Fe plus 3 are in contact, Fe will convert it into Fe plus 2, Fe3 also converted into Fe plus 2. That means the concentration of Fe plus 2 is increasing and Fe plus 3 is decreasing. So here in these options, Fe plus 3 increases, wrong. Fe plus 3 decreases. Oh yes, Fe plus 3 decreases, this is correct. Fe plus 2 remains unchanged, wrong. Fe plus 2 decreases, this is also wrong. So second option is correct.